Hi there, this is Dr. Sonia, Assistant Professor, SNS College of Technology. As a continuation of the previous video, for the determination of hardness of the given water sample, we're going to see about what is the reaction between the EDTA and the metal ions that is present in water. So how the buffer solution is prepared is by weighing 67.5 gram of ammonium chloride and 570 ml of ammonia are dissolved, and the solution is made up to 1000 ml using distilled water. So what is the experimental procedure involved over here? First is standardization of EDTA solution using standard hard water. So you're going to take burette solution EDTA, pipette solution you have to pipette out 50 ml of standard hard water. Then the additional solutions are 10 ml buffer solution, indicator is areochrome black tea indicator. So when the titration is done, the end point, that is, there'll be a color change from wine red to steel blue, which is the end point of the titration. So how do you calculate this? You have to take the volume of EDTA as V1 ml. 1 ml of standard hard water is equal to 1 milligram of calcium carbonate. 50 ml of standard hard water is equal to 50 ml of calcium carbonate. So 50 ml of standard hard water requires V1 ml of EDTA. So V1 ml of EDTA is equal to 50 ml of calcium carbonate. So 1 ml of the EDTA will be equal to 50 by V1 milligram of calcium carbonate. So how do you estimate the total hardness of water sample using the standard EDTA solution? So again, the burette solution is the same solution, but you will have to pipette out 50 ml of sample water in this titration, and the additional solution is 10 ml buffer. Indicator is areochrome black tea indicator, and the endpoint is again from the steel blue wine red to steel blue color. So here you have to calculate the volume of EDTA is given as V2 ml. So 1 ml of EDTA is equal to V2 into 50 by V1 milligram of calcium carbonate, and 1000 ml of the given water sample will be equal to V2 into 50 by V1 into 1000 by 50. So that the total hardness will be 1000 into V2 by V1 in ppm. So how will you estimate the permanent hardness of the water using standardized EDTA solution? So this is the third titration. So you're having the 100 ml water in 250 ml beaker. So boiled for temporary hardness, cool and filter, then made up to 100 ml. So again, it's the same burette solution, but the pipette solution is 50 ml of boiled water sample, and the additional solution is buffer, the indicator, and the endpoint is from steel blue color. So how do you calculate this? Volume of EDTA is equal to V3 ml. So 50 ml of the given boiled sample water consumes V3 ml of EDTA. So 1 ml of EDTA is equal to V3 into 50 by V1 mg of calcium carbonate. So 1000 ml of given water sample is equal to V3 into 50 by V1 into 1000 by 50. So here we are going to have that is equal to 1000 into V3 by V1 mg of calcium carbonate. So permanent hardness is equal to 1000 into V3 by V1 ppm. So temporary hardness can be calculated by the equal to total hardness minus the permanent hardness. That is equal to 1000 into V2 by V1 minus 1000 into V3 by V1. So this 1000 into V2 by V1 is the total hardness, and minus 1000 into V3 by V1 is the permanent hardness. So temporary hardness will be given by 1000 by V1 into V2 minus V3 common in a bracket, and the unit is in ppm. So these are the various steps to determine the hardness, that is total temporary hardness, permanent hardness, and the total hardness of the water sample. So it is followed by the first iteration is the standardization of the EDTA using standard water, followed by two more titration. One is to find the temporary hardness and another to find the permanent hardness, and the total hardness and the permanent hardness are determined. From that, the temporary hardness of the given water sample is estimated. So this experiment is of more value. So it is used to find the hardness of the given water. Thanks for the patient listening. Thank you.